Okay, I finally made it out to some of these islands to do some videotaping, and this particular island I'm on is called Cool-Pix Island, and it's just off Hernando Beach Channel. There's a boat ramp there, and that's where I go out when I want to go down to what we call Arapica. There's some buildings out here that's approximately 10 miles away, and you can go on Google Earth and you can calculate it in, and to these apartment buildings is approximately 10 miles. So I got a 10-mile zoom on this thing, and what I've done too is I put this in half speed so you can actually see the mirroring off the water, and all these other effects that occur. One of the things that I was looking at was refraction. Refraction in physics, the change in direction of a wave passing from one medium to another caused by its change in speed. For example, waves in deep water travel faster than in a shallow. And what I'm looking at is water, is the evaporation rate that's going on between me and these buildings, which this also causes a distortion. And when you look at distorting an object, and there's many things that you have to take into consideration, refraction of light, the miraging effect, vanishing point, your depth perception, atmospheric conditions, which is humidity, evaporation rate, the water molecules in the air, and then you got this heat wave effect, which is part of that distortion. You also have this angular resolution going on, which creates this mirroring effect. Glare, too much glare where the sun is located in the sky is also going to contribute to what we see out in the far distances. Water vapor. Water vapor is the water molecules in the air. So when you start taking all of these things into account, you can start seeing that some of these things are not what we see. Mirage, an optical effect that is sometimes seen at sea, in the desert, or over hot pavement that may have the appearance of a pool of water or a mirror in which distant objects are seen inverted, and that is caused by the bending or reflection of rays of light by a layer of heated air of varying density. Now, we don't have this going on in this, but what we do have is we have the mirroring effect, the miraging. This is not a mirage. You can actually see the buildings, and I'm going to probably insert a couple of photos into this to explain what I see when we're looking at these buildings. I've already passed over it, but if you look down at the edge, at the bottom of the buildings, you see these big square windows. And as you go from the top window down, the windows appear to get bigger. That is part of the distortion. If you go into, say, a house of mirrors, you will see how these, the mirroring effect will distort your body. It will change, your appearance. There's different kinds of mirrors, and that's due to its bending, the light bending in these mirrors. As a child, I went to some of these, fun houses. Now, I'm going to jump over, and this is a tower that's out there, and look how clear it is. The higher up I go, it doesn't seem to be distorted. Why? Because a lot of the evaporation rate is happening at the lower part of the water, and that's what causes the distortion. So, as I go through this, you're going to see some pretty neat stuff. You're going to see birds flying around. You're going to see birds walking around. You're going to see their reflection on the water. You're going to see their shadow, their reflection on the water. So how can I be seeing this if this earth is curved And then we have also in here, we have the vanishing point, where your camera can no longer see past this point due to all of the atmospheric conditions that are in the water. Um, let's see, a mirage is a natural occurring optical effect in which light rays are bent to produce a displaced image of a distant object or the sky. The word comes in via the French mirage from Latin uh, mirari, mirari, meaning to look at, to wonder at. Um, when you watch this video, I mean, this is just an awesome view. This is awesome. How can we be seeing these things flying low to the water, birds walking in the water, um, and you'll even see and hear some fish, some mullet jumping out of the water. Um, vanishing point, a point of disappearance or extinction. His patience has reached his vanishing point. Well, we don't need that one. Um, a point at which parallel lines receding from an observer seem to converge. The point is linear. Perspective at which all imagery lines of perspective. In other words, everything's mashing down to a point to where just as I zoom into these islands, they're just a little sliver out in the distance. And this little sliver is really, really hard to um, see as far as your depth perception, but as I zoom into it, this landmass seems to rise up. So it rises up to where you can actually get some detail from it. These channel markers that I've got on the screen right now are approximately 3 to 5 miles away. So how in the world am I even seeing these? And you see the layers of the water where you got calm spot, ripply spots. The further you get away, the longer those little ripples are. In other words, you're seeing this compressed, mashed, just like I showed on my fish tank experiment, where the farther you get away, your depth perception is deceived because you can't really judge your distance because of the angular resolution too that I'm at. But you can obviously see these channel markers out there, and as I zoom into them, some of them you can definitely see the color green and red on them, and that's something that's actually amazing too, that I'm even picking up the coloring with my camera. Now as I zoom back, see how everything just kind of mashes or gets smaller, and then when I zoom in it gets larger. That's basically what we have to do when we're zooming a long distance. But there's a point there where I no longer, or my camera can no longer pick up anything past this point due to the atmospheric conditions. We're always told that when you look at a mirage, don't believe your eyes. Don't believe what you see. Now, you'll even see the reflection of the clouds in the water that are above. If you look close enough, you will actually see these. Um, so, why are we being able to even see the distances that I'm seeing right here with my camera? Because the earth is not curved, it is flat. And this particular day, it was a very, very low tide, not much wind, because where I'm actually at with my camera, a lot of times it's underwater. And I've got other videos that I made after this, quite a few out. I mean, I think I had a couple hours out here on this island that I videotaped. And I'm actually going to videotape an 180-degree spin. I'm going to go from north to south and viewing from toward the west, being that this is in the Gulf of Mexico. And I even do show you a little bit toward the east. I do a little 360 spin. But even these, look at in the background, you'll see flashes of light. you'll see these islands that I zoom in on. Now, I'm not sure, but I believe that this is an island somewhere out there, but I'm not exactly sure. I mean, you can see what looks like a boat just to the left side of that island, and it's kind of flashy, it's distorted, and you can't really see anything on it as far as real definition. And that's due to all this miraging effect, this mirroring, this heat wave, this distortion. And this is all part of a whole mix of things that you have to take into consideration when you're zooming out and looking at these long distances, especially with cameras with the optics on it, especially the Nikon Cool-Pix P900 has some awesome zoom power. But you do have a lot of these things, like I was saying before. You got the refraction of light, you got the mirroring effect, vanishing point. Your depth perception is kind of thrown all out of whack because you're not sure where you're, how far out these areas are. Atmospheric conditions, you got the humidity, evaporation rate, water molecules in the air, this heat wave effect, or the distortion effect, I should call it. Angular resolution, and that's the height of me as the observer zooming out to this horizon. This is not the horizon line, by the way. The horizon line is higher. My camera is not perfectly level at this point. I am on a little downward angle. And to get that exact level point is very hard to do on a camera. I mean, with this camera, you can probably do it by setting a level on the barrel of your lens. Being that this barrel is pretty long, you probably put a small level on it and get it as level as possible, but you're still not going to get it exactly perfect. And, depending on, too, where that sun is in the sky, also causes some effects to your zoom. So if I'm zooming away from the sun, say the sun when I was on the East Coast and I was videoing the boat and the horizon, it didn't seem like I got as much of this mirroring effect or this miraging effect as I do pointing southward, which this is pointing southward, and the sun is more south of me. So in turn, this is causing some issues with my visuals. Now, again, watch right here. I do believe you'll see it. Let's see, you see the little mark on the left-hand side, the little flashy light, and then you see another one to the right of that. But watching that general area right there, I believe you're going to see a fish jump. It's a mullet, and it'll jump twice if I haven't already passed it. If not, back up the video and watch it again, because you will see this little fish jump. And that's something actually amazing that I've seen in a couple of my videos, that I was actually seeing these mullet jumping at long distances, which is kind of crazy that I could even see these little fish jump. And this is one of the reasons why I slowed this video down, was to give you a good view of everything that's in it, so your eyes can take in as much as you can. And if you even go to your YouTube settings and slow it down even more, you might even see more than what I'm seeing. So again, when we watch these videos that people put out of these long distance shots at the horizon, people will tell you that, oh, it's just a mirage, and don't believe your eyes, don't believe you, just go on about your way, you're just seeing things. There's the fish, and he's going to hop again. Give him a second here, or maybe he just did do the double hop. There he goes. Ah, look at that. You see that fish jump twice. So, how can I be seeing these things? If if the Earth is curved. I mean, that right there should have already been over the curvature. A lot of the things that we see out there are just distorted images. It's not because it's an illusion, and it's not because it's being popped up from the other side of the curve, like, you know, the Chicago skyline video where they say, oh, you know, it's because of the way the light was hitting and the heat and the air and all this bull crap to tell you that, you know, this thing was popped up from behind the horizon line. Bull crap, you know. They tell us this stuff just to get you to not believe. And that's another thing that we'll discuss later on is belief. What is a belief? Because it was kind of funny when I typed in or even asked my phone the definition of belief. Um, and what is a horizon line? In real life, the horizon is where the land or sea and the sky meet. And painting perceptive, it's the level your eyes are at an imaginary line to which things recede. So things recede because they get smaller, and the smaller they get, the harder it is for your eyes to see, or even a zoom camera to see. So, you know, again, you have to take all of these things into account when you're looking at these long distance zooms and why you cannot see past it. Why does this thing just look like it's floating in the air? Because the water itself turns into a mirror at a certain distance, and you can see that throughout this whole video. And all it's doing is reflecting the sky. So you're not going to see anything past that point due to everything is receded down, flat, mashed to the ground, and it's probably just this little bitty old speck that you can't even see. And then you have everything else that causes you not to see it, and that is, like I say, a lot of the humidity, the atmospheric conditions. Now, if I had a cool, very, very dry day, I might even be able to see farther. My camera might be able to pick up things at a farther distance. But because of Florida and its humidity, we very, very seldomly get a lot of dry days to where we can see at long distances due to, like I say, the evaporation rate. And that evaporation rate at the surface of the water is very high. So you have a lot of that water molecules floating up, causing you to actually be looking through water. And what does water do? Water distorts an image. So by distorting this image, you get this wavy effect. It doesn't mean that this thing, there's another fish jumping up out of the water there, right beside, there he goes again, double jump. So again, you know, how am I seeing these I mean, tiny fish? I mean, a mullet ain't very big. Miles away from me. Miles away. So, you know, again, you know, we have been taught to believe a mirage is just something that you just can't believe your eyes because, you know, hey, it ain't there. It's a hallucination. No, there's a difference between, you know, if you were walking through the desert and you know, your body is about dehydrated, and then you start hallucinating. You might see this beautiful paradise island out in the distance, and that's more or less a hallucination. And there you could not believe your eyes. But my camera does not hallucinate. So, you know, my camera is not seeing a hallucination. It is actually seeing objects out there on the water. Now, look at these birds when they fly over. You'll see their reflection off the water. And then sometimes you'll actually see these birds disappear as they're flying, like that one right there, and then it pops back up. Why does that occur? And I'll tell you why. Because there is what they call I call it an invisible zone. It's an invisible area that you cannot see. And that's part of where things seem to disappear at. You know, like the missing part of your building, or your missing part of your horizon line. That's because of the mirroring effect. If you stand in front of these mirrors in a fun house, I mean, some of them, as you walk up to them, you know, parts of your body disappear. And again, that's all due to all of these things that I had mentioned before. You know, the miraging effect, the water molecules, the humidity, the evaporation rate, all of these things are happening, but science will tell you don't believe your eyes. You're not seeing this. This is all being popped up over the curvature of Earth. You know, there's no way you could actually see these things, so they're going to come up with an excuse to say that you're not seeing these items, these objects. But all right, here for instance, I see out there, I see this tower. And this tower is from Anclote Island, which is over 25 miles away from where I'm at. But I can see the lights flashing on it. And, you know, it's pretty obvious that the top of the tower is not as being having this miraging effect as lower toward the water. Um, and as I get lower toward the water, you will actually see it reflecting itself. Now, there's going to be something here at the bottom as I go down. Now, I slowed this part down to like 33% to let you view it a little bit longer. And then I'm going to drop down and show you these lines, these water lines, which, you know, this is part of that depth perception. How far out am I going? Each one of these little slots is probably, you know, hundreds of yards, if not thousands of yards in between each one of them. And that's where your depth perception is thrown off. As I bring my camera down lower, you can see a little bit longer lines. That means that these lines are still long. There's long distances in between them, but you can see the farther out you go from these lines, they get smaller and smaller. And that's part of that depth perception. How far away are we zooming? And again, that's part of that angular resolution, refraction. Now, these little rocks that are beside this tower, or what appear to be rocks, could be part of a landmass that my camera's picking up. Now, you just seen those lights flash on the bottom and the top there, and those two bands right there that you see where those lights are flashing, I think in between there is where I can focus at. That is where things disappear. That's why you cannot see any landmass back there. That's my vanishing point. That's that invisible zone that you cannot, my camera cannot pick up any optics in that area due to all of that atmospheric condition. Now, two, all this water in my way actually will ramp up and cause me to like deflect up off the water and into the air, because the air is water. Okay, so this mirroring that's occurring right there is being mirrored off the air, not so much off the water. And that you have to take into consideration too. Now, I have another video that I'm going to put out where I'm zooming south at or at Citrus County. There's a power plant up there. It's the nuclear power plant up there. The one down here is a coal operating plant. But I'll show you that one in another video. Now, look at here. Here's a dolphin swimming out there. And, and you'll see later on here this dolphin. It's pretty awesome when you look at this. But take in all these other things that you're seeing too. And this dolphin is going to come into the picture again later. You see the water even glistening around this thing moving in the water. You'll see its fin pop up. And later on here, like I said, I get a better shot of this dolphin. And then I zoom back away. And I should have zoomed all the way back when I caught that dolphin, but I do a short pullback and then I zoom back in on it. But I should have pulled all the way out to show you how far out that well, where I'm standing at the observer, there's no way that I could see that dolphin with my naked eye. I can't see half of this stuff. I can't see these birds. None of this stuff with the naked eye, of course, because the Nikon Cool-Pix P900 has such an awesome zoom. It's ridiculous. It's literally ridiculous. And again, you know, you see all of these shadows or reflections of the birds as they fly. So what you're seeing is a reflection off the water. It's not off of some invisible or some lifted up horizon from over the other side of the curve. Okay, so what you're actually seeing is you're seeing right here to the left, you're seeing the very last part of the landmass that I can pick up. And here comes that dolphin swishing through the water. Now, how in the world am I seeing this dolphin at the distance that I'm at? And again, you know, I'm going to pull back here shortly and show you how far back I actually am, but I don't pull back nearly as far as what I could have. Okay, so my camera could actually pull back even more. So again, you know, when you look at the very beginning of my video, you see things that you say, wow, you know, wow, what am I seeing? And then if you even look in the far background on some of these zooms, you will see little lights flickering in the far, far background. What they are, I can't say, but there are little lights flashing back there. And I'm really happy that I slowed this video down to where you could take in a lot of this stuff, because it really helps people understand why you can't see from sea to shining sea. Okay, because of the atmosphere, plain and simple. You got so much atmosphere in the way. You know, evaporation rate causes all this water molecules to go into the air, which causes that refraction even more. You know, it's, you know, zoom through water. You know, ask a scuba diver when he's videoing the water, you know, what's his visibility? Well, you know, the more water that's in his face, you know, he can't see as far. And the clarity of the water makes a big difference too. Now, as I'm zoomed out here a little farther, I probably should have slowed that down a little bit more too, but I didn't. But you can actually see these reflections of the clouds in the sky. Now, what are we actually looking at? Well, again, you know, when you're splitting some of these things in two, you can't exactly split them in two because that mirroring effect doesn't cause equal portions. I thought it did. I thought when I was looking at things, I had an equal portion. Like if I split this island in half, that would be the top half and the lower half. But it's not exactly that way. It's a little bit different, and you can see that in the buildings at the very beginning. The buildings were much taller, the real buildings were, compared to its reflection. But its reflection was actually being casted out a long way, but because of that depth perception, you couldn't really tell. And these are some of the clouds right here that I'm referring to that you can see how they're reflecting in the water. It's kind of hard to tell, but if you really, really look at it, you can see a big difference in it. And that's what this whole video is about, is to show you that, you know, long range viewing has many, many problems with them. But the problem isn't due to the curvature of Earth. The problem is due to optics, distortion, evaporation rate, all of those above things. So, you know, when we're going to view these things and look at them, you got to view them with the open mind that why can't I see farther? And why can I even see some of the things that I can see at the distances that I am seeing? Again, you know, science is going to come out and say, oh, you know, it's because of this, it's because of that. But they always seem to sweep evidence under the rug and disregard what you have to show. And these are facts that, I mean, you can check into many, many different subjects. And if it doesn't meet their requirements, or doesn't fall into their definition, then, you know, they're going to tell you that, you know, this is something that you're not seeing, that you're hallucinating or you're imagining it. But, you know, when you got it on video and you can actually prove it, again, you're going to get your skeptics, you're going to get your deniers, and they're going to come on and they're going to attack you. And then sometimes they even attack you as the person. You can attack me all you want. I'm just an average Joe trying to show really good pictures and really good proof that we don't live on a ball. We live in a flat plane of existence, and if you don't like it, get off. Go into space and see where you wind up. Now, I guarantee you, you're going to be dead, right? Because there ain't no space. You just got high altitude balloons or high altitude. They can make it to high altitudes, but that's it. They're not never making it into space. Well, I hope you enjoyed my presentation, and I hope you liked it.